Hello, pre-calculus students, and welcome to the lesson on double angle identities, half angle identities, and power reducing identities. And before we get started into the business of proving things, let's just look at kind of an overview of this and what these identities are good for. So if you look at all of these identities, these equations, we always start out on the left-hand side with cosine of 2u or sine of 2u. And then we are able to reduce this angle into cosine u, sine u. Same for all of these here. So once again, the theme of this whole chapter is that you have an expression that's trigonometrically difficult because you have something complicated in here. And then you're able to convert it into something that's simpler. So the inputs here are a simpler expression, but there's more of them. There's the algebra gets a little bit more complicated. Okay? And in this particular chapter, this section, we're dealing with double angle identities when you have two u's, or when you have half angle identities, which is the angle divided by 2, or power reducing, meaning how do I go from sine squared down into something that doesn't have a square in it? How do I go from cosine squared to something that doesn't have a square in it, and so on. Okay? And so let's get started with our very first proof here. So we're going to prove the sine of a double angle identity. And I'm going to rely on sine of a sum to do this one. So I'm going to start with the left-hand side. And I'm going to rewrite this using sine of a sum. So instead of sine of 2u, it's just going to be sine of u plus u. Okay? And I'm going to write my reason on the side here. This is sine of sum, and this becomes sine of u cosine u plus cosine u sine u. Okay, so it's sine of a sum that gives me that expression. And you can see that these two terms here, these are like terms. They each have a sine and a cosine, a sine and a cosine, albeit in slightly different order, but that doesn't make a difference here. So we can combine the two like terms together, and we get 2 cosine u sine u. Okay. And this is equal to the right-hand side, so we are done with that proof. And one note to make here is, from this proof, you can see that we're really just applying the sine of a sum. So I'm going to make a note here that double angle identity is a special case of sine of a sum, or a cosine of a sum. Now the next one says to try it on your own, and you should certainly do that before you hit. So you should hit pause, try this on your own, and then go back to the video if you still have a hard time with it. Okay, and so if you did have a hard time with it, this is how it's done, and we're going to follow the same concept that we did up here. Left-hand side is really just cosine of u plus u, and then we apply the cosine of a sum, okay, so applying the cosine of a sum, and then we just have to simplify, and so this is cosine squared u minus sine squared u, which is equal to the right-hand side. Okay? And so following with kind of the same reasoning and explanation up here, all of these double angle identities that I have listed up here, they're just special cases of sum, of the sine of a sum or the cosine of a sum. And if you notice, we have actually 3 different versions for the cosine of a double angle, and this is both sort of Mixed blessing, I mean, it's a blessing because it gives us more options when we have to solve problems. It's a little bit of a mixed blessing because now you have to think a little bit more on which one to use. Okay, but in general, it's going to be more helpful to have more options. Okay. And so there you have it, just kind of a brief introduction into double angle identities. Watch the next videos to see some more complicated examples to see how we get these other proofs done.